So this video is we try to compute the n-dimensional sphere, the volume of n-dimensional sphere. Okay, so the key point of this video is n-dimensional sphere. So basically, we want the volume and the area. I should say, okay, surface area. Okay, so so volume is the n-dimensional volume, and the sphere is a -1 dimensional object. Okay, so the n-dimensional sphere basically I can embed it into Rn plus 1. So Sn just defined to be x1, x2 up to xn plus 1, such that if you sum of these, there's no absolute value, but it's fine that it's 1. Okay. But when we do a derivation, that okay, so I can let this r to r, this is r to the square. Okay, so the key point is to calculate this one, that we can use the famous integral to help us. So this is the square root of pi. Sorry, I think square root of pi divided by 2. Okay. So the key point is that we can collect lots of these. So if I change minus infinity to infinity, then this is square root of pi. Okay, so the standard technique is that we take n-dimensional integral. So basically we take n of this, and this is pi to n over 2. Okay, so this is basically the integral space is the whole space. Okay, so we can take write it as this dx1 up to dxn. So this is pi n divided by 2. Okay, so the key fact is that you can change this. Okay, so let me remind you guys, when you do the dx dy, then you will change it into r dr this data, and then you got 2 pi r dr this data, r dr, and then in 3D. So okay, so if you take only f of r, then you will write f of r is 4 pi r squared dr. Okay, so 4 pi is what? So 4 pi is the surface area. Surface area in 3 dimension, and 2 pi is the surface area. Basically, it's the 1-dimensional object. So I can view as a surface area of 1D. Okay, sorry, of 2D. Okay, so from this analog, then we can write this dx1 to dn to be the let me write. I write it as a of n. So a of n just the radius 1 sphere. Okay, so surface area of the radius 1 sphere in n dimension. So this one is just r, and in 3D you will got r to the 2. This is r, so it's r n minus 1 dr. Okay, so we change it to a polar coordinate. So this is the final calculation, what we need to do. Okay, we'll become this. Okay, so the final computation is very easy. We just write a of n, pull it out. Okay, so this is the final integral we need to do. Okay, and let me just directly tell you the answer. So remind you guys that this is the gamma function. Okay, so it tells you that so if you do the change of variable, then you will have another gamma function transform. Called it you can let t equals to r squared. So you have this r2x plus minus 1 dr times 2. Okay, so from here, what we got is this. It's just so 2x minus 1 should equals to n minus 1. So this is gamma n divided by 2. Okay. Okay, so this is gamma n divided by 2. So finally, I should write there's a half. Okay, so this is the area. Okay. Okay, so this is the surface area. So how about we calculate something? A of 2, just 2 pi 1 divided by gamma function of 1. Also, gamma function of 1 is just 2 pi, it's just 1. So let me remind you guys that gamma n is just n minus 1 factorial, and the gamma of half is just square root of pi. Okay, so a of 3, just 2 times pi 3 over 2, and divided by gamma 3 over 2. So just the gamma 3 over 2 just half times square root of pi. So this is just 4 pi. So this is coincident with what you guys know. Okay. So finally, we need to calculate the volume. Okay, and the volume is trivial. That I guess everyone knows about key point. Basically, supposing 3D, this is your volume, and then you just differentiate respect to r, then area is 4 pi r squared. Okay, so that means in the radius. Okay, so the area of Sn sorry, I should say the area of sphere with radius r in n dimensional should be it's just this one, right? So the volume of r just integrate with r. So what we have this is r minus 1. Okay, so just integrate with r. So this is what we have. Okay, amazingly, this can be written as n over 2 times gamma n over 2. So this is pi n over 2 gamma n over 2 plus 1 and rn. Okay. Okay, so let me summary. So the area in n dimensional with radius r is just 2 pi this. Okay, and the volume r in n dimensional just pi 2 to n gamma n divided plus 1 r n. Okay, so this is our final results. Okay. Okay, I think it's not very difficult. And I have a remark that you guys should think about. A remark is that fix r. Suppose somebody fixed like r, put r not greater than 0, then what is limit n diff goes to infinity a of n, and limit goes to n infinity this v of n. Okay, so I mean once you fix the radius, then what is the volume in when the dimension goes to infinity? Okay, so this is the question I hope you guys can think, and basically, and I hope you guys try to find the meaning of this limit. Okay, that's it, because I think this question is very familiar, very common in calculus. So I give a short proof. Okay, and I will see you guys in the next interesting videos.